math friends. Today we're going to work on estimating square roots given benchmark square roots. If you want to find the full lesson of this, you can find it under the ordering rational numbers lesson. So this is just a snip of that. All right, the first thing we're going to do is we're going to tell students that sometimes you might not need a calculator and you're going to want to simplify square roots. You're going to do that by estimating and comparing it to the closest perfect square. My perfect squares can be found below. I've got square root of 0 all the way through square root of 100. The first thing I'm going to have students do is I'm going to have them associate this perfect square with its simplified version. So here it's already giving me square root of 1 is 1, square root of 4 is 2, and I have some blanks on this number line where I'm going to fill it in. So I'm going to have students fill in all these missing ones. These are already given for me, and now I'm going to fill in the rest of the number line. Here's the number line filled in. This is going to be helpful because when we have imperfect squares, we're going to use the closest perfect squares to estimate its value. This is really helpful if they're not given a calculator. So I've got my perfect squares here. The first thing I'm going to do is I'm going to look down here. It says locate the following numbers on the number line. So I have square root of 20. I know that that's not a perfect square, so I'm going to find where it falls on this number line. I know that square root of 20 is going to fall somewhere between the square root of 16 and the square root of 25. It's going to be closer to the square root of 16. It's only 4 away from that. So I'm going to put it right here at about, let's say it's about 4.4. Not quite half, but I'm going to write the square root of 20 here just so I don't get confused. All right, next I have the square root of 27. The square root of 27 falls between the perfect squares of square root of 25 and the square root of 36. It's going to be closer to the square root of 25, so I'm going to mark it closer to the square root of 25, which is going to give me square root of 27. I'm going to say that that's about 5.2. Again, it doesn't have to be perfect. We just want to give an estimate. Next, I have the square root of 32. I see that that's also between these two values. It's going to be closer to the square root of 36 this time. So I might say that it is 5.6. It's a little over halfway. And last but not least, I have the square root of 18. And the square root of 18 is going to fall even closer to the square root of 16. It's going to be between these two. So I might put it about right here. I'm going to do a nice little curvy arrow here, and I'm going to make it to the square root of 18. Since it's closer to 4, in between 4 and the square root of 20 here, I'm going to say that it's about 4.2. And that's how you estimate imperfect squares given perfect squares on a number line. Thanks for joining. Happy teaching.